All right, today we talk about factoring. And factoring for us is really going to mean, or we'll say usually, is the process of writing a polynomial as the product of two binomials. And in our future lessons, we'll do something a little bit different and we'll give it a new name after that. But an example of this would be seeing something like this. So instead of seeing it as x squared minus 4x minus 21, you would see it as the product, which means multiply, of two different factors. And those are binomials, the two parentheses. All right, at any point in time, if you guys get behind or anything, just let me know. We have a bunch of examples to do today. So in the process, first we're going to check to see if there's a common factor. That means, is there anything that goes into all of the terms that you see? And then, if there is one, factor that out first, and then continue the factoring process. And then what we're trying to do is usually find two parentheses that multiply to give us what we see as a polynomial. So for example, as I look at number 1, in my head what I'm thinking is, does anything go into all three things? The answer is no. So then, I write down two parentheses. And as I write down these two parentheses, what I'm thinking to myself is, I see an x squared, so I need an x times an x to make that x squared happen. If you're ever in doubt, and you're not sure what to write down, that will always be your first step. Two parentheses with x's in the front. And then I need two numbers that when I multiply these two numbers, I get positive 12. And I also need those same two numbers to add to give me 7x. So what two numbers can I multiply and get 12 and add and get 7? 3 and 4. So I write down positive 3, positive 4. Because positive 3 times positive 4 is the positive 12 I see in green. And positive 3 and positive 4 added together give me positive 7x. If you were to check this, you could FOIL it back out, which is what we learned last lesson, and see that you would produce what you started with. So there's always a way to check your work. In the next example, same kind of deal. Does anything go into all three things? Nope. So I write down my two parentheses. I need to get that x squared out when I FOIL. So that means when I factor, I need an x times an x to make that happen. And then I'm looking for those two numbers, first of all, that have to add to negative 10 and have to multiply to positive 9. So two numbers.
So it will always be the x that you want it to add out.
Correct. Always want to add to the x, multiply to the number. Two numbers that multiply to give me positive 9, but add to give me negative 10. Naima?
Negative 1 and 10. Negative 1 and 10.
Negative 1 and 10 multiplied together give me negative 10. So that will not produce the green. Gabe? Negative 1 and negative 9 will work. So notice that I had to have negative 1 times negative 9 to give me positive 9 in the green highlight. But negative 1 plus negative 9 gives me negative 10 in the yellow highlight. In number 3, I'm looking at two numbers. Well, first of all, I look to see common factor. Nope. Usually you're not going to have a common factor unless there's something in front of the x squared. Usually. So now I write down my two parentheses. X times x gives me that x squared. Two numbers that add to give me the negative 20. Or sorry, multiply to give me the negative 20. And add to give me the positive 9. Positive 5 and positive 4. Done. Good. In number 4, no common factor again, so I have x times x for the x squared term. Two numbers this time that add to negative 11 and multiply to 18. Agree?
Negative 9 and negative 2.
Negative 9 and negative 2 is correct. So negative 9 times negative 2 is positive 18, and negative 9 plus negative 2 is negative 11. Number 5. No common factors again, nothing that goes into all three things. So I have x times x to get x squared. Two numbers that would multiply to give me negative 4 and add to give me negative 3 are minus 4 and positive 1. So as I look at these, the negative 4 is produced by negative 4 times positive 1, and the negative 3 is produced by negative 4 plus 1. In number 6, looking for the common factors again, I see none. So parentheses, x and x to produce the x squared when I FOIL that back out in my head. Two numbers that give me negative 12. Oh, wait a minute. What's in front of the x?
1.
A 1. Don't forget, just because they don't write it there, doesn't mean it isn't there. So I'm looking for two numbers that when I multiply, I get negative 12, but when I add, I get negative or positive 1. Naima?
What you said?
Here.
Negative 3 and
Negative 3 and 4. Positive 4?
Yeah.
Okay, so negative 3 times positive 4 is negative 12 in the green. Negative 3x, positive 4x is positive 1x. Looks good. Good job. And then the last row here on this page, I look to see if there's anything that goes into all of them. I don't see anything, so I write down x times x in my front of my parentheses. Don't forget you have to have parentheses, 2 of them, when you're doing this process. I'm looking for two numbers. First, I'm looking for the numbers that multiply to give me 36, lots of combos, but they must also add to give me negative 12.
Positive 6 and negative 6.
Positive 6 and negative 6 would add to give me 0,
I mean,
and they'd multiply to give me negative 36. I need positive 36. Very good, Tom. I need negative 6 and negative 6. And then, of course, all the super math studs like you guys are going to write this as x minus 6 squared, because there's 2 of them. You are. Yeah. Number 8, no common factors again. So I have x times x. Two numbers that are going to multiply for me, and they're going to give me negative 8. But when I add those same two numbers, I get positive 7. Positive 8 and negative 1 is correct. Good job. Okay, in this particular set of examples, kind of the cool thing is that we're going to talk about something called the difference of two squares. If you see two terms, just two things, not three, and you look at the first thing, and you could take something and multiply it by itself and get that, and the same with the last thing, and there's a minus in between them, that's called the difference of two squares. And this is what always happens. When you see that occurring, you will have two parentheses, and the first thing in each parentheses will be the square root of the first thing that you saw. And the last thing in each parentheses will be the square root of the last thing that you saw. And there'll always be a plus and a minus. That's called the difference of two squares. So x times x, that's the x squared that you saw first. Positive 4 times negative 4 is the negative 16 that you see. And the reason that there's no middle thing is if you look at the inners, positive 4 times x, that's 4x, and the outers, x times negative 4, that's negative 4x, they always cancel out. And that's why there's no middle term. Okay, example 2 then. In example 2, I see two things. Both happen to be perfect squares. So the square root of x squared is x. I place that in the front of each parentheses. The square root of 64 is 8. I place that at the end of both parentheses. And then one's a plus, one's a minus, done. That's it. Every time.
Number 5 is
Don't jump so far ahead. Number 3. Two things, both are perfect squares. Two parentheses, square root of x squared is x, so that goes in the front. Square root of 1 is 1, so that goes in the back. One's plus, one's minus. Number 4, just because they're reversed, the number and the letter thing, no big deal. 25 is a perfect square, x squared is a perfect square. I write down the two binomials. This time the square root of 25 is 5, so that goes in the front. And the square root of x squared is x. One's a plus, one's a minus, done. Doesn't matter if the number's first or last. Number 5 looks a little more complicated. Don't let it fool you. The 81 is a perfect square. The x squared is a perfect square. That's all one term. The 49 is a perfect square. So I write down my two parentheses. The square root of 81 is 9. And the square root of x squared is x. So I write those down as the first thing. And the square root of 49 is 7. One's a plus, one's a minus.
Can you feel that?
I know that.
Oh, good. Kayla, what'd you get?
It's x squared
X squared in front and
and 5 y
and 5y in the back. Very good.
and plus and minus.
And plus and minus. Done. Super easy. Super fast. So if you see two things with a minus in between, and those two things are perfect squares each, super fast. Look at the last one, number 7. What's different about this one?
Plus.
There's a plus. This one, if there's a plus,
Minus.
you just write down can't factor. Why? Because there was a plus in there. It's not going to happen. The end.